Tuesday, worksheet number 5 on velocity time graphs, starting with question number 1. The velocity of the object at 6 seconds. This is like finding a position on a position time graph, right? If you want to find position on a position time, velocity on a velocity time, momentum on a momentum time, acceleration on an acceleration time, what do? Up and over, right? So at 6 seconds, we go up and over. When we do that, it looks to be, oh, it's hard to see it this close. It looks to be 5, isn't it? Oops, ooh, what happened there? Let's try that again. We go up and over at 6 seconds. It looks to be 5 meters per second. When you're this close to the graph paper, to the grid marks on this, it's hard to see. So if I make a mistake on that, just let me know. Plus, when your eyes start going on close-up things, those two things act against getting correct answers sometimes. 2, the change in velocity between 0 and 9 seconds. This is just up and over, and subtract the 2, right? At 0 seconds, we look to be 1 meter per second. That would be the initial. The final at 9 seconds. What is it? This is 9 seconds right here. You go up and over, that looks to be 7. So we're going to say 7 minus 1 is 6.0 meters per second. So my change in velocity. The acceleration of the object, that's the slope of the graph, but the slope of the graph is exactly the same thing as delta V over delta T, right? Rise over run, delta Y over delta X is delta V over delta T. It's going to be 6 meters per second divided by the time from 0 to 9 seconds. That's 0.667 meters per second squared. I wonder how many of you get this one right. The displacement of the object seems not too bad, right? Because it's a triangle, right? Not quite. Not quite a triangle. We have, in this one, a couple of shapes, whether you noticed it or not. We have a triangle right here, but we have a rectangle right here. Right? How many of you got the rectangle and the triangle? Okay, if you missed the rectangle, that's okay. Don't miss it again, though. Don't miss it when it counts on a quiz or a test. We got to include everything between the x-axis and the line. And in this case, we have a rectangle and a triangle between the x-axis and the line. By the way, if this line was below the x-axis, we'd still calculate it, right? It would just be negative, a negative displacement if it's below the x-axis. Positive above, negative below. So I'm going to call this rectangle number 1, and I'm going to say the area of 1 is base times height, which is 9 seconds times the height of 1 meter per second. That gives me 9.0 meters. And area 2 is 1/2 base times height. Base is 9 again. The height is, well, I went from 1 to 7. The height is 6. So that's 27, I think. We add those up, and it gives me 36 meters. How many people got 36? Good. Good for you guys. Now, we weren't asked to find the average velocity here, but if we were, we would just take the displacement that we just found, 36, and divide it by the total time of 9. And what would it be? 4, I guess, 4.0 meters per second there for the average velocity. We could use, Jacob, you were talking about V equals D over T earlier, I think. We could use D equals D over T there if we were asked for the average velocity. But since it's accelerating, we could only use it if we were asked for the average velocity. All right, next one. The velocity at 6 seconds, up and over. At 6 seconds, it looks like 4, isn't it? 4.0 meters per second. Next question, number 6, the change in velocity between 0 and 8. Watch this. This is one that people get wrong on quizzes and tests. Between 0 and 8 seconds, the change in velocity is VF minus VI. The final velocity at 8 seconds is 0. The initial is 16 meters per second. The change in velocity is not 16 meters per second, but rather it's negative 16 meters per second, right? How many people put the negative there? Good. We need the negative, right? We need the negative. This is a quiz or a test. Instead of 1, 16 would have got you a 0.5 out of 1, but like, I don't know about you, but I'd rather get it completely right than partly right. 7, the acceleration of the object. It's the slope of the graph, right? Whoops, where are we here? Something's going on here. There we are. Yeah. Wow. I don't know what's happening here to this morning. It's the slope of it, right? Or we could say A is equal to delta V over delta T. The delta V is negative 16 meters per second over the time of 8 seconds. Gives me negative 2.0 meters per second squared. Hey, how come that's negative? I mean, mathematically it came out to be negative, right? But, like, should it have been negative, Marshall? Yes, it's moving in the positive direction. People look at this and say, oh, wait, isn't it moving in the negative direction because it's slowed down? No, it's not. Look, the velocity is positive through this whole question. It's positive. It's to the east, this whole question. It's moving to the east through the whole question. It's just slowing down in that positive direction. So that would make a negative acceleration. And math is elegant. Whether you like math or not, sometimes you have to appreciate the elegance of it, right? We know that it should come out to be negative, and guess what? The math made it negative. It just always works that way. When it should be negative, math makes it negative. We don't have to fudge anything like that. And the displacement of the object, this one's easier, if I can get to it. Oops. If I can somehow get to that. There we are. There we are. The displacement of this is just the area, and this is just one triangle, right? So we're just going to say the area is 1/2 base, which is 8, times the height, which is 16. That gives me 64 meters. Good. How many people get 64? Okay, good. The average velocity, Jacob Chata, would be? I'm asking you. You know why I'm asking you. How come? What would the average velocity be? How would you find the average velocity? Nope, the average velocity. V is equal to, correct, V is equal to delta D over delta T. We just found the displacement. It's 64 meters. The time is 8 seconds. That's going to be 8.0. Actually, 8.0 meters per second. I almost tricked myself for a second. I was thinking it should be a negative 8, right? But it didn't come out to be negative 8. It's not supposed to be negative 8. Just because it's a deceleration, it's slowing down, doesn't mean it's a negative velocity. It's not. It's a positive velocity the whole time. The average has to be positive. And again, the math made it positive. Okay, 9, 10, 11, and 12 here. 9, the velocity at 12 seconds. I don't know what is up with this morning. Should I just hit it? Okay, let's go with this. The velocity at 12 seconds, we go up and over at 12 seconds, and it looks to be 5 meters per second. The acceleration between 0 and 8 seconds. 0 and 8 seconds, that's going to be A is equal to delta V, bless you, over delta T. That's going to be what? 5 minus 0 over 8. 5 over 8, I think, is 0.625. Is that right? Meters per second squared. It's positive. The math made it positive and should be, right? It's speeding up in the positive direction. The acceleration between 8 and 18 seconds. What is it?
0.
Yeah, did you show any work for that?
No.
Do you need to show any work for that one? No, we know it's 0 because it's a flat line on a V versus T graph. Now, if you did, A is equal to delta V over delta T, the final velocity would be 5. The initial velocity would be 5 over the time. 5 minus 5 over the time is 0. There's no need of showing any work, though, if you know that it's 0. And the displacement of the object, number 12, 2 shapes here. We got a triangle and a rectangle. Call this number 1. Number 2, area 1 is 1/2 of, what is that, 5, 6, 7, 8, times a height of 5. What is that, 20? And area 2 is base times height. We're going from 8 to 18, I think. So the base is 10 times the height of 5, which is 50. Add those up, it gives me 70 meters. How many people got 70 meters there? Good. Okay, I'll give you a couple minutes here to finish up this worksheet now, 13 to 16. It should only take you a couple minutes. See what you can do. All right, let's have a look at question 13. The acceleration of the object between 0 and 25. I suspect that people didn't have a whole lot of trouble with questions 13 and 14. I suspect the trouble came with 15 and 16 for most people here. Those were a little bit challenging. Not so much 16, but 15 for sure was a little bit challenging here. The acceleration between 0 and 25 seconds. All we're going to do for this is, or we could say A is equal to delta V over delta T, which is what I like to do, or you could say slope is equal to rise over run. It's the same thing, right? The rise here is 80 minus 0 over the time, 25 minus 0. So that's going to be 80 over 25, which is 3.2. Is it 3.2? Meters per second squared. How many people got that? Good. 14, same thing here, rise over run or delta V over delta T, but remember here that delta V is, careful, what's VF? What's VF here between 25 and 45 seconds? At 45 seconds, how fast does this thing move in center? Right. And initially, at 25 seconds, it's moving at 80, so it's 0 minus 80, not 80 minus 0. The time interval here would be 20 seconds. This is negative 4.0 meters per second squared. How come it's a negative value? Well, because the math showed it's negative, but in the real world, why is it negative? Because it's slowing down in the positive direction. Good. Now, this is where it gets trickier here. A number of people stopped me and asked me about this, and I stopped at a number of other people's desks and pointed out something as they were making the mistakes on this too. So this is a very, very common mistake, especially at this point here. We want to find the displacement. Everybody knows that the displacement here is the area, right? Everybody got that. Okay? I don't think anybody made a mistake on that, but it's just how we find the area. Here's what a lot of people did. A lot of you did. And I get this completely. Okay? It's a common mistake, and it's such an easy thing to do, especially at this point here. To find the area here, a lot of people say, well, I'll calculate this, make this a rectangle, and then I'll break it up into however, like, whatever. We don't do that. Okay, we don't want this area down here. Okay, we want the area between the line and the x-axis. Picture this for a second. If I was to whoops, that's not what I want to do. If I was to have a graph that looked just like this, then we wouldn't dream of calculating the area down here somewhere, right? Underneath the x-axis. We would calculate the area of this rectangle right here. We'll call it number 1, and the area of this triangle right here, right? Well, if all of a sudden it starts moving in the opposite direction, that doesn't change what's already happened. So we're not going to all of a sudden say, oh, now it's moving down here. Now we got to start calculating this area down here. No, we don't. Okay, what's already happened has already happened. The displacement is that rectangle and that triangle. What's happening now is section 3, the triangle that exists between the line and the x-axis. Does that make sense? Okay, remember, if that section 3 isn't there, this is what we do. Everybody would get this correct. Everybody would get that correct. So if we add section 3, then don't mess up what everybody already knew. Just add to what everybody already knew by calculating that area. So let's do that now. Let's say area 1 is a rectangle. Its base times height, which is, what is that, 2 times 10? Area 2 is, what are we going from 2 to 7? So the base is 5, the height is 10. Is that 25, I think? It's a triangle, so area 3 is 1/2 of, what's the base here? We're going from 7 to 15, the base is 8. What's the height here? Negative 20, good, negative 20. So what's that, negative 80, I think? 20 plus 25, subtract 80 is negative 35. So displacement here is negative 35. It's not negative because this is below the x-axis. It's negative because there's more in section 3 that's negative than is positive, right? Some of our displacement is positive, but there's more negative than positive. So overall, it's a negative displacement. We end up to the west, right? And finally, we want to find the average velocity here. Let's say it's displacement divided by the time, right, Jacob? Displacement divided by the time. Displacement is negative 35 meters divided by the time of, what is it, 15 seconds? Is that 2.33? Negative 2.33? Is the velocity always negative here? No. Look, it's positive up until about 7 seconds. And then what happens at 7 seconds? What happens at this point right here at 7 seconds? Yes? Okay, so it changed direction. So what did it do as it was going at 10 meters per second, 10 meters per second, 9, 8, 7, 6, 5, 4, 3, 2, 1, stops. And then what happens? Starts. What's it doing right now? It's speeding up, right? In the negative direction. So it was slowing down, stops, changed direction right here, and then speeds up in the negative direction. There's your unit test, which is still a ways off here, has a series of multiple choice questions and written questions. And one of the multiple choice questions is similar to what I just asked you there. I asked about the interpretation of what's happening as it's going down here, right? Slowing down, slowing down, slowing down, slowing down, stops, changes direction, speeds up, speeds up, speeds up, speeds up in the opposite direction.